I think we're ready to go. So, another official welcome to our webinar, Mastering Multicloud Connectivity with Ficolo and Megaport. My name is Antti Kivalo. I'm the Sales Director of Ficolo and will be the host for today. We'll be spending about an hour together, and I'm glad and thankful for all the people joining us. It's great to see you, so many of you on board. I'm here joined with Paul McGuinness, the Head of Solutions from Megaport, who will be doing the actual presentation, and Philip Zöpf, who is the Sales Director of Benelux and Nordics in Megaport, who will be concluding a summary of Megaport after Paul's presentation. Firstly, I'll go through just a couple of slides about Ficolo. Many of you already know Ficolo. We have been around for 10 years, and there's many customers online, so hi all who I know, and great to see you there. Ficolo is a cloud company who has its own data centers, and we believe in cloud engineering and right-sizing your cloud environment. And we think that every customer is different, and we think that we need to craft the right cloud solutions for every customer's specific needs. We provide clouds and co-location and the best of both worlds. We deliver public cloud, and when you need more, we can of course build a hybrid cloud and the connectivity solutions we're talking about today to combine the best of private and public clouds. Of course, you all know already who know Ficolo that we're really aware of the data security and the greenness of our company. Like already told, Ficolo was founded in 2011. It's fully Finnish owned, and we have made a huge investment in our newest data center here in Vantaa. And we have offices in Pori. The headquarters are in Pori and then Helsinki. And we're 40 people total altogether. We grew 60% 2019 and 30% 2020, and it looks like we're growing a little bit faster than 30% this year. And we're glad that we're able to serve so many customers. We have about 160 customers. We have 3 data center locations. We have 2 actually in Helsinki, 1 in Pori and 1 in Tampere. The last year we have certified ourselves with ISO 27001 and ISO 22301, and of course we have done some customer specific certifications, for example with the Finnish Defense Forces. The PCI DSS, the financial standard, is almost ready. We have already audited our site, but haven't gotten the certification yet. We have always been using green energy, and we have now our own solar power plant in Pori. Clouds and co-location, what does it mean? It means that we can actually manage public clouds, all the brands the customer wants to. We have, on top of that, we have our own data centers and the own cloud management tools. And of course, we also offer private cloud, either through our resellers or then when the need is specific enough, we can do it also by ourselves. And the cloud connectivity is the key to basically all of this. This is something that we cannot do without great connectivity, which is provided by our partner Megaport. You can see that green energy and heat reuse is a rising subject in the cloud area as well, and we're really proud to be the greenest data center provider in the Nordics. And this was basically it. Going to our subject, we deliver cloud delivery network via Megaport, and you can see that we have connected our own sites with Megaport, and we call it the Ficolo Cross Connect. The Ficolo backbone, you can have direct access to all of our 3 data centers, and of course then via the sea cable to Germany, or then another route through Stockholm, where we are able to connect to over 700 data centers and all of the public clouds with the service provided by Megaport. And now I'll hand it over to Paul. Paul, please continue with your presentation, and at the end we're going through the questions and answers. You can put those in the chat box, and then we'll answer those questions later. Paul, please.
That's great, thanks, Antti. Yeah, my name is Paul McGuinness, Head of Solutions, as introduced earlier. And today, what I'm going to run through are these items. So it will be fairly technical, but I think there's still really good information in here for anyone who's also interested in the aspects about connecting to cloud. We're going to focus on AWS and Azure, the private connectivity models, and we'll then look at the cost items as well, and the things that you should consider when connecting to the clouds in a private way. And then we'll go through and talk about mastering multi-cloud later on with Philip. So moving on, just a quick terminology comparison to kick off with. For AWS and Azure, the concepts are very similar, but there's different terminology depending on which cloud you're talking about. So for AWS, the private connectivity method is the direct connect. For Azure, it's called an ExpressRoute. They're fulfilling very similar things, but they do it in quite a different way. So direct connect for AWS, ExpressRoute for Azure. In AWS terms, they use the terms VPC for the virtual private cloud, the place where you keep your workloads. In Azure, that's your virtual networks or VNets. And then we'll get into the gateways in a while during this presentation, but AWS uses 3 different types of gateway for private connectivity, whereas Azure uses a virtual network gateway. And then you'll note within the compute area for AWS, it's typically referred to as EC2, whereas in Azure, it's virtual machine, and then so on with S3 and blob storage. So let's just jump into the first part, which is covering AWS. Now, there's 3 parts to the connectivity models for AWS. There's the models themselves, there's the virtual interfaces, and there is gateways. And in each of those sections, there are 3 elements. So let's kick off and just talk about how this connectivity construct is available and the different options that are open to you. So the first are the connectivity models. There are 3 of those. So dedicated, hosted connection, and hosted VIF. Let's look at dedicated first. Dedicated is where you go into your AWS console, you select the location of your choice, and you deploy a dedicated direct connect. AWS will give you a letter of authorization that shows you where to physically connect into AWS. So this is typically between the customer going directly into and connecting into AWS in a location of choice. It works very well if you happen to be in the same data center as AWS or very nearby. It does have some constraints in that if you need to get a second resilient location, you have to reach out using a last mile provider, for example, to get to that second location. And then if you want to get to other clouds, you have to sort of repeat the process. But it is an option that can be used. It supports 1 gig, 10 gig, and 100 gig interfaces. The next model I'm going to cover is AWS Hosted Connection, and this is a partner model. So in this model, if I just pull up the drawing, what you have is the ability to basically connect to a service provider in any location around the world. So you plug into the service provider, and then the service provider fulfills all of the connectivity towards AWS, and they take care of all of that interfacing into the cloud that you need, in this case AWS. And for hosted connection, this is a fixed data rate connection. It starts at 50 megabits per second and then goes up in steps, 100, 200 megabits per second, and so on, right the way up to 1 gig, 2 gig, 5 gig, and 10 gig connections. It is a dedicated model giving you dedicated bandwidth, and it also calls out high availability zones. So you've got a blue zone and a red zone that you can easily see are there, and it allows you to deploy in a resilient way. This type of connectivity supports transit gateway, which we'll get to a little bit later. It also supports private VIFs and public VIFs that we'll explain later on. Okay, so the next model is hosted VIF. And just to contrast how this is with the previous model of hosted connection is a fixed data rate. If you want to change the data rate, you have to reprovision the circuit to change that data rate. Hosted VIF, on the other hand, is a flexible model. So you can turn that up and down. You can start at 1 megabit per second and scale all the way up to 5 gigabits per second. And you've got a lot of flexibility there. In addition, the port fees on the AWS side are absorbed by Megaport in this case. So you as a customer would connect into Megaport in any of our 700 data centers, typically here in a Ficolo data center, and then we can get you to the cloud location of your choice, into the region of your choice. It doesn't have to be a local one if you don't want it to be. It can connect to anywhere in the world, and we'll get you to that cloud location, that AWS cloud location of your choice. The drawback with hosted VIF is that it supports a public VIF and a private VIF, just like hosted connection, but it does not support a transit VIF. So if you need transit gateway, then hosted connection is the best option for you. And incidentally, for accessing transit gateway, you do need to have a hosted connection at 1 gigabit or greater. Okay, so the next part is to cover off the virtual interfaces. We've touched a little bit upon them already, but let's go through those 3 interfaces. There's private, there's public, and there's transit. So here are 2 examples of the way to use a private VIF. The top example is showing you how to connect a private VIF into directly into a virtual private cloud through a virtual private gateway. The lower example is connecting a private VIF through a direct connect gateway and then virtual private gateways into your VPCs. And the private VIF is really, it's your way of accessing your virtual private clouds and all of the workloads that you have inside those virtual private clouds. The next interface is a public interface. It's probably less popular than the private virtual interface, but it is still a fairly common model that people use, and they use that to get to publicly available services on AWS cloud. An example of that might be S3, for example. If you needed to get to your S3 data inside AWS, you would use a public VIF. Again, that goes through the exact same partner or dedicated models that we looked at earlier to reach your public services inside AWS. And the final type is the newer of the lot, which is transit virtual interface. The transit virtual interface allows you to reach that transit gateway. It does pass through a direct connect gateway as well on the way to get there. And then that allows you to connect to many different VPCs. So it allows you to reach up to 5,000 attachments on that transit gateway. And it's a very popular model over the last couple of years. If you do want to provision a transit VIF on a partner direct connect, then you do need to be connecting on hosted connection with 1 gig or greater, like I mentioned earlier. So finally, let's just cover the different gateways just to bring it all together. So first, there's a virtual private gateway. And as we saw earlier, and we're showing in this example, you can use a private VIF to connect into your virtual private gateway to get you access to your virtual private cloud. Using this gateway, it gets you just one-to-one access if you use it in this way with a private interface. If you want to have more capabilities on your direct connect to get to more virtual private clouds, then you can use the next type of gateway, which is a direct connect gateway. Using a direct connect gateway allows you to get to 10 VPCs, and those VPCs can be in different accounts, and they can also be in different regions. Now, in this case, the connectivity is going, let's say, west to east, east to west. Basically, the traffic is flowing from the virtual private cloud across the Direct Connect gateway through the service provider, in this example, down to your device. There's no transitive routing, or there's no connectivity between VPCs, in this case, through the Direct Connect gateway itself. So it's just providing you that connectivity back to on-prem. There are other ways using the transit gateway and VPC peering to get from VPC to VPC, but not through the Direct Connect gateway itself. So this does work very well for customers, or for people who want to have a small number of VPCs, maybe 10 or multiples of 10, because you can spin up multiple Direct Connect gateways to get you that access to those virtual private clouds. If you need to scale much larger than that, then you're looking at Transit Gateway to get you that functionality. And that leads me into Transit Gateway. So you can see a Transit Gateway using a Transit VIF connected through a Direct Connect gateway is then associated with a Transit Gateway, and the Transit Gateway can then be connected into many thousands of virtual private clouds and other services as well. So in all of these cases, it is going through a virtual private gateway as it connects into the virtual private cloud as well. So there's lots of VIFs, gateways, connectivity models. We're running through them quite quickly here today. You know, I'm quite happy to take a call directly with anyone afterwards if they want to go through this slower or in more detail. We are taking questions as well, so please do put your questions into the Q&A section, and we'll get to those at the end. We'd love to hear from you as we go through this session. Okay, so let's look at ExpressRoute. Again, ExpressRoute has 3 different models that we're going to talk about today. There's ExpressRoute Direct, ExpressRoute Partner, and ExpressRoute Local. So let's jump into those. Before we do that, we're going to just cover off a few concepts here just to set the scene. In Microsoft terminology, the VPCs are called virtual networks, so VNets. So we'll use those terms interchangeably as we go through this. The ExpressRoute Virtual Network Gateway is a logical routing function, and it's something that works in a similar way to the virtual private gateway in AWS. So when you spin up a virtual network gateway, you'll assign a gateway subnet. Behind the scenes, it's a number of virtual machines that Microsoft instantiates and looks after. You can't directly manipulate those, but you do need to have your virtual network gateway up and running to associate that with an ExpressRoute. There are also Microsoft Enterprise Edge routers, and these are 2 routers that are in highly active availability configurations, and these allow you to connect in a redundant way into an ExpressRoute. So when you create an ExpressRoute, it will automatically always create a primary and a secondary connection, each going into a separate MSEE router. Okay, so let's look at the first model. We've got ExpressRoute Direct, and this is very similar to the AWS Direct Connect Dedicated. In this case, you're taking that authorization from Microsoft and you're connecting into the MSEE routers on the ExpressRoute side. You've got some options to connect at 10 gigabits per second or 100 gigabits per second. If you connect in at 10 gigabits per second, you can provision SKUs of 1 gig, 2 gig, 5 gig, and 10 gig. And if you physically connect at 100 gigabits per second, you've got SKUs available to you of 5 gig, 10 gig, 40 gig, and 100 gig. Again, this can be great if you're in the same DC as the ExpressRoute peering location, but it has a few drawbacks in that you are tying up that connection just to that specific location. If you want to reach out to other peering locations, then you've got to reach out to those separately. And if you want to get to other clouds in a multi-cloud scenario, you're basically replicating this over and over. So the next option that we'll talk about is when you do this connection through a partner or a service provider. So obviously this is something that Megaport is offering, and here on the left-hand side, we're showing, a customer device connecting to the service provider. That could be anywhere in the world, and the service provider will fulfill the connectivity into the Microsoft ExpressRoute across the service provider network and get you access to the MSEE devices in the peering location of your choice. The speeds that are available start at 50 megabits per second, and then they go up in 100, 200, 500, and then 1, 2, 5, and 10 gigabits per second. You can increase the data rate in a seamless way. If you want to reduce the data rate on an ExpressRoute, then you need to re-provision that ExpressRoute, which is, in a partner model, it's a very quick and simple process to do. Okay, ExpressRoute Local is the other one that I wanted to talk about, and it's kind of a special case, and it's where you're connecting at an ExpressRoute peering location that is similar or is local to the location of your virtual networks. So that means that the peering location and your workloads in the cloud are local to each other, and Microsoft identifies which peering locations are local to which part of the network within Azure Cloud. This is really useful when you've got high volumes of egress data, because with ExpressRoute Local, you connect using this local SKU, but then you do not pay for any egress fees. You have to connect at 1 gigabits per second or greater, and we're going to cover the pricing for this later. But it can be something to consider if all of your workloads are in a particular Azure region, and you want to connect through a peering location that's local to that. And Megaport can help you get to that local region if it's not something that you're physically near to yourself. And what that would look like, using the earlier diagram, in this shaded area, we're showing that the MSEE devices where the ExpressRoute peering location is in the same or near to the same Azure regions where you've got your workloads up and running. Okay, more about that a little bit later. So within Azure, there's two peering types. There's private peering and Microsoft peering. So let's just jump into private peering first. So for private peering, you can bring up two BGP sessions between your device and the MSEE devices on the Microsoft ExpressRoute. You set up that routing. You can set up route preferences. You can use ECMP to load balance over the primary and the secondary link. And one of the good things about this ExpressRoute is that you can access up to 10 virtual networks that are anywhere inside the geopolitical region, for example, inside Europe. And just to spend a little bit of time on this point, because it's really important and it's something that's often misunderstood. Within an ExpressRoute, for example, if you go to any of the 18 ExpressRoute locations that are available in Europe, that allows you to reach any of the 12 regions on a standard SKU for that ExpressRoute. So for example, if you connected in Stockholm to an ExpressRoute peering location there, you can reach any of the 12 Azure regions inside the European geopolitical region. So it's pretty flexible and pretty powerful to be able to do that. If you want to reach outside this geopolitical region, then you can just switch on the Premium SKU that allows you to get global connectivity to other regions as well. So it's worth bearing in mind. So even though you're connecting in an ExpressRoute peering location, you're not locked into that location. You've got a lot of scope that you can play around with. Okay, so private peering, it's like the diagrams we saw earlier. This is the partner model where you're connecting to a partner. The partner can then get you to your peering location of choice. And then in this example, we're showing using the Premium SKU, the ability to connect into EU West. And we've also got another Azure region here at the top for US West. So the customer can do that from a single peering location. Microsoft peering, it also has, there used to be another peering called public peering. It's now part of Microsoft peering. So if you hear people talking about public peering, they're probably meaning the Microsoft peering aspects. So this is connectivity to Microsoft online services. It could be things like Microsoft Dynamics or Office 365 or other PaaS services. Office 365 was really created to be accessed across the internet, and as such, to get the best experience, Microsoft has put a review for all customers wanting to connect across ExpressRoute. You can go onto the website, select review, that will take you through a questionnaire, and there'll be some consultation there before you are given the go-ahead, the green light, to access Office 365 across ExpressRoute. They just want to make sure everything is going to operate correctly and there's no asymmetrical routing or inadvertently sending data around a long way when you provision your ExpressRoutes. You have to create route filters, and the customer does that themselves when you're using Microsoft peering, and you can use things like BGP communities to filter routes and to receive only the routes that you want on that Microsoft peering. So Microsoft peering, it looks to be, a similar model from the connectivity aspects right the way up to the MSEE routers. Then you provision your routing, and that allows you access to those public services. So now we've talked about the two different peerings, and then I'm actually using a Microsoft diagram here from their website. You can bring these two peerings together and use them at the same time. So to be clear, the Microsoft peerings here at the top right, and the private peering is here at the bottom right. What is typically used is Q&Q to use both of those peerings on your connections back to your devices on-prem. And that means you will have two connections into Microsoft, into the two MSE devices. You'll have a primary connection and you'll have a secondary connection. In the primary, you could have both peerings, and inside the secondary, you can have both peerings. So you're using that Q&Q facility to have multiple peerings traveling across both the primary and the secondary connection. Now, it's not mandatory. You don't have to use both peerings in this way. There are a number of different options. And in fact, at Megaport here, we've just added a recent functionality that allows you to do away with this requirement. So if you only have a single peering and you don't want to use Q&Q, which can be problematic for certain organizations who maybe have equipment that does not support that, we've got an option to remove that Q&Q requirement and just to pass down a single 802.1q tagged interface to the port and then onto your equipment. So we just make it easier. We've got a number of different options that are well documented, and I'm happy to run through with anyone who's interested in that. Okay, so next let's look at the cost components for AWS and Azure. First, we'll look at AWS costs. So the Direct Connect cost components are broken down like this. We've got them for dedicated, for hosted connection, and for hosted VIF. For dedicated, there's a port fee. So that's an hourly fee for a 1 gig or 10 gig interface. And then there are egress fees. And the egress fees, for example, in Western Europe are 2 cents per gigabit. And that 2 cents per gigabit is significantly lower than the egress fees for going across the internet. And the egress fees are actually the same for dedicated, for hosted connection, and for hosted VIF. So the 2 cents is relevant there. The fact that it's much, much lower than internet fees can be great, can give you great savings if you're doing a lot of egress traffic. On a dedicated connection, you can have up to 50 VIFs, and that can be a combination of public or private VIFs, but you can only have one transit VIF. So if you're wanting to get to transit gateway with that one VIF, you do have to think about the fact that you might have different types of traffic coming from different types of VPCs going over that transit VIF. So you might have your production traffic mixing with some staging traffic or some dev traffic as well. And that can be a limitation for many customers. Hosted connection, using a partner model. In that case, there is a port fee, and that is an hourly fee, and it depends on the rate that you're connecting at. So that starts at 50 megabits per second, and it goes up to 10 gig, with obviously a varying port fee for each different data rate. Usage fees are the same for the egress fees that I've just covered before. And in this case, it's 1 VIF per hosted connection. So that means you can create private VIFs, public VIFs, and transit VIFs. Private and public VIFs can be on any of the connectivity speeds, but if you want to have a transit VIF, you have to be connecting at 1 gigabit or greater. Okay, so that allows you some flexibility. So for example, if you wanted to have multiple transit VIFs, you can provision multiple transit VIFs. If you want to mix that with a hosted VIF, you can do that as well and separate up your traffic, how it makes sense and how you want to do that. Hosted VIF on the right-hand side has got a, does not have a port fee. Megaport will absorb the port fee, so it can be very economical in that respect. It has the same egress fees, and you can either have a public or a private VIF, and that's speeds from 1 megabit per second up to 5 gig and any increment in between. Okay, Azure costs. Now, we've just seen AWS costs. We summarized that on one slide. Azure costs are a little bit more complicated. So let's go through the different elements of this. It is nicely explained on their webpage. It takes a little while to digest it. Again, I'm happy to go through that with you and explain it all, but let's go through this right now. So ExpressRoute has 2 billing models. There's a metered and unlimited. Metered inside the European zone is very similar to AWS fees. It's 2.2 euro cent within the European region. And there's also then the unlimited option as well. So you'll pay a higher SKU at the start, but then you will not pay any egress fees. And incidentally, just to mention, obviously, the data going into cloud is typically free with all of the CSPs, and then the data coming out is often metered with AWS, Azure, and Google as well. So then let's cover the standard versus premium SKUs, and we'll also talk about the local SKU. So the standard SKU allows you to have 10 virtual networks on a single ExpressRoute. And that allows you to have to advertise up to 4,000 routes towards Azure. And like we covered earlier, with a standard SKU, you can get to any virtual network inside the geopolitical region, and that is a wide area. A premium SKU supports up to 100 virtual networks on a single ExpressRoute, and that allows you to advertise 10,000 routes, and that allows you to get to any virtual network in the globe over the same ExpressRoute circuit. It also allows you access to Office 365 and the global reach facility as well. And then here on the right-hand side, we've got the local SKU. And like I covered off earlier, that's where your workloads and the ExpressRoute peering location are local to each other. It has the same limit on resources as the standard SKU, so that's 10 virtual networks, for example. And it only allows you to use local SKU at 1 gigabit or greater. Okay. And then we've got the different cost components as well within Azure. So if we break those down, for dedicated, you've got a port fee. So you've got a 10 gigabit per second or 100 gigabit per second port fee. You've got your egress fees based on the zone, and the zones are detailed on the Microsoft webpage, but inside the European zone, it's one large area that most people on this call will be concerned with. And that can get you the standard, the premium, or the global add-on SKUs that you can apply to dedicated. For the ExpressRoute partner model, you've got a port fee depending on the size of the connection, so the data rate that you provision. Incidentally, when you provision the data rate, for example, if you created an ExpressRoute with 100 megabits per second, that gives you a primary and a secondary, both with 100 megabits bidirectional, obviously, on that. The usage fees, again, depend on the zone. if you're on a metered billing model, and that allows you standard, premium, and global reach add-on as well. The local one is a slightly different one again. So there's a port fee based on the circuit bandwidth, 1, 2, 5, or 10 gig, but then there's no egress fee. So if you're doing a lot of egress and you've got that capability to have your workloads local to the peering location, then the local SKU might be something that works for you. And here's some pricing examples. So we've got standard, premium, and local. If we look at metered first, we can see that a standard metered is 368, whereas premium is 1,000. So you can see how these costs are varying. For unlimited, we've got a standard of 4,800 and a premium of 5,400. So not a huge difference between the two of those to get those additional premium features. But you can see here the local SKU for a 1 gigabit connection is only just over €1,000 per month. So if you can design your network in that way, that could make sense, and then you don't pay any egress fees. And then likewise, you can see that that gap is much greater if you look at unlimited for 10 gigabits per second. The standard and premium are actually quite similar, and then the local SKU is much, much lower. Okay, and then just to finish off my section, I just wanted to highlight as well that there are a few other costs as well. So there are charges for the virtual network gateway on the Azure side. There's 3 different types of virtual network gateway that are there. So there's a 1 gig, 2 gig, and 10 gig, depending on the performance that you need. And those are charged on an hourly rate. So you should bear those in mind. And then just to add on that it's something similar. If you're starting to use transit gateway, you have to pay per attachment, and you also have to pay for the traffic passing through the AWS transit gateway as well. So these are all things that you need to think about when you're looking at your connectivity models. You're looking at the costs that you have to incur as you go to the cloud. So I hope you found that useful. Keep your questions coming in, and I think that's as far as I'm going to cover off today, and I'm going to hand over to Philip at this point.
Yeah, thanks, Paul. That was very interesting and very insightful. So I will present a quick overview about Megaport, so where we're coming from and what we do. So Megaport is an Australian company founded back in 2013 by the entrepreneur Bevan Slattery. Today, Megaport employs about 260 people and generates about 30 million euros of revenue. So when Megaport was founded, we had one goal in mind. It was to create private interconnections as easy and seamless as possible. That can be a point-to-point connection between a specific colocation data center or a connection to any of the hyperscalers, which you can see listed on this slide. Megaport operates a global network infrastructure and manages this network through software-defined network. This network enables fast, flexible, and on-demand connectivity to hundreds of global services with a global footprint throughout APAC, North America, Europe, and the Middle East. It is a pure pay-as-you-go service model, and connections can range from 1 Mbit to 100 gig, and this is depending on the data center. On our Megaport portal, you can establish seamless point-to-point connectivity between regions and cloud service providers from your physical data center, or without the need to own and manage your own hardware. And you can keep your traffic secure when connecting between metros, regions, and countries. We connect enterprises, cloud service providers, data centers, and network service providers. So how does Megaport's ecosystem look like? We serve then more than 2,300 customers globally. We work with more than 102 DCOs, data center operators, and as a consequence, we have presence in more than 700 data centers and we provide private connectivity to more than 360 service providers. Within this ecosystem, we offer our services with our unique value proposition, which is scalable and on-demand bandwidth, a multi-cloud service offering, and a private and secure cloud connectivity, and very flexible contract terms, which I will come back later. So this slide is very important because this shows the difference between the traditional connectivity model and the connectivity model Megaport provides. So firstly, price. How can I obtain commercially competitive pricing? If you go to your WAN provider, for example, and order connectivity through the traditional methods, you will no doubt request a quote from your account manager, who will come back to you in 2 or 3 days with a quote. If the quote is acceptable, you'll need an order form. And once again, if you're lucky, and you will get an order form within 2 to 3 days. You will sign the order form, send it back to your account manager, and typically wait for another 1 to 2 weeks before you receive acknowledgement of your order form and installation date, which, depending on your carrier's infrastructure, could be another 19 days plus before you access the cloud service provider is complete. So this whole process takes far too long, right? So through a NaaS provider like Megaport, you can obtain pricing online and order your cloud connectivity via an easy-to-use portal, and subject to the provision of a cross-connect, spin up your connectivity to the cloud in less than a minute. Furthermore, if your capacity requirements change as you add more and more applications and workloads to the cloud, you can add bandwidth and effectively pay for what you use. By the same token, if you need to scale back your connectivity access to the cloud, this can be achieved via our online portal in seconds. And once again, you will only pay for what you use. Another thing you will need to consider is how long you require access to the cloud for. Your WAN provider will most likely try and get you to commit to a long-term contract of between 12 months, 24 or 36 months. Whereas under the NaaS model, the minimum term is only 1 month, and your consequent connectivity to the cloud is charged on a pay-as-you-use basis in exactly the same way the public cloud providers charge. You also have the option of entering into a long-term contract, of course, which will attract discounts here. So you have the best of both worlds. The Megaport network as a service solution has been built upon an underlay of the best breed carrier networks and underpinned by a comprehensive SLA. All of the features provided, which I have mentioned, can be accessed via the Megaport online portal, which is really simple to use. And of course, if you want or need a demonstration here, Paul and I are always happy to help, and we can arrange a meeting and walk you through the process of our Megaport portal. So cloud and partner network. All our locations are listed on our website. This is always growing all the time. You can go on our website, look under the locations tab, and you will see all the details are in there, including the physical and also latency figures between the different locations. The locations you can connect to Megaport include all of these data center providers. We are all in these different operators around the world, which means you have got a lot of choices here. For our customers, that means they just have to get to the nearest data center. In most or many cases, our customers are already in the same data center as us. So for instance, Ficcolo here in this case, all they have to do is order a cross-connect from the data center provider to connect to the Megaport network. And last but not least, here are 4 different connectivity models, or let's say the most common connectivity models we offer. Beginning on the top left here, the ability to spin up a port in data center 1 and another in data center 2 and have a flexible layer 2 low latency connection between those two data centers. So that means you can have a connection between 1 megabit per second and 10 gigabit per second, and you can turn up and down as you need to. Moving to the top right here, this is where customers have got one port in the data center with us, and they can connect to multiple clouds from that single port. Ideally, they are in the same data center as us. Otherwise, they order a last mile connection from their WAN provider into our data center. And we then will give you the low latency layer 2 connections there. Bottom left is the Megaport Cloud Router, as we call it, the MCR. And here you've got the ability on a layer 3 connecting cloud to cloud. And bottom right is putting it all together. That's a hybrid connectivity from a data center with a port in a data center. You're connecting them through a layer 3 MCR device, a virtual device in the location of your choice, where we have them deployed, and then the ability to connect into multiple different clouds. This gives you cloud-to-cloud connectivity. All right, so questions. I see one question which was answered by Paul directly. All right.
Yeah, let me just cover that question. So there's a question about what would be the advantage of using Transit Gateway versus using AWS gateways to exchange traffic between VPCs. The advantages are really down to the fact that things like the Direct Connect gateway does not allow traffic to flow from one VPC to another VPC. So the Direct Connect gateway is only allowing traffic to go from the VPCs back to on-prem. So that's not a solution for connecting your VPCs together. There is the ability, and it's been a feature been around for a very long time, the ability to connect your VPCs together or to peer them together. That works at small scale very well, but it doesn't scale very well. So the more VPCs you have to peer them one-to-one in a one-to-one relationship. There's no transitive peering there, so you can't daisy chain them together and expect them all to communicate. You have to peer them on a one-to-one basis. So Transit Gateway will make sense for you if you have a lot of VPCs, or if you need that VPC to VPC communication at any type of scale. Okay, great.
Right.
So, yeah, keep your questions coming in.
Yeah, I've got another one here.
Yeah.
Why not use a dedicated connection to cloud service providers versus a partner connection?
Okay. I think I mentioned it a couple of times that dedicated can be a good option if you happen to be in the local location of the Direct Connect or the ExpressRoute. And then I pointed out that it does tie up that connection that you've got, and it's again a one-to-one relationship. So if you want to get a second peering location or a second Direct Connect location, then you do have to find a way of getting to that other location if you want that type of resilience. So the dedicated option is there. It can be used. There's also some limitations around using a transit VIF on a dedicated connection to AWS. You can only have a single transit VIF on a dedicated connection. So you've got to put everything down that one virtual interface. So using the partner model allows you to connect once or maybe in two locations with Megaport, for example, and then all of that connectivity to cloud can go through the same physical ports. So you can have connectivity to Azure and AWS on the same port, and then later add in Google if you need it, or Oracle, or whatever else you want to add. And of course, you can connect port-to-port anywhere globally on our network as well, to replace MPLS type connections as well. So if you had a connection in a port in Singapore and one in Oslo, you can connect those two together at data rates of 1 megabit per second to 10 gigabits per second.
All right, thanks, Paul. Here is another one. If I have 20 to 30 AWS VPCs, do I need a transit gateway?
This is what we would probably sit down and talk you through, what your requirements are. Maybe we can have a call later and talk about the details. But if you've got a smaller number of VPCs, so 20 to, let's say, 40 VPCs, then you could use direct connect gateways to get to those. Then it depends on, do you need your VPCs to talk to each other? If you do, then transit gateway will make sense. But if you only need those VPCs to communicate back to on-prem, then maybe a direct connect gateway will work for you, and that could be more economical for you as well. It'll mean you'll avoid those transit gateway costs. And of course, if you need to evolve to transit gateway in the future, that's all very easy to do, particularly through the partner model. You just add additional virtual interfaces, provision that connectivity, and then just scale the way that you want to.
Okay, and I think there's a last one here. When using a direct connect to reach AWS, I cannot advertise more than 100 prefixes, or AWS, the BGP session will drop. Is there anything Megaport can do to help in this situation?
Yeah, this is a common problem. So on an AWS Direct Connect, you're only allowed to advertise up to 100 prefixes towards AWS. If you go over that limit, then the BGP session will be dropped by AWS. So people are highly conscious about their prefixes. It is a concern. You need to look at what you're advertising towards cloud. Many customers have this capability on their on-prem devices, but some don't, due to the devices and the network that they have on-prem. We do have the Megaport Cloud Router that Philip covered, and you can spin up a Megaport Cloud Router in a location that makes sense. It has route filtering capabilities, so you can control what is being advertised towards AWS. And indeed, that also works really well when you're connecting to multi-cloud. So if you're connecting to Azure and AWS, you can filter out which prefixes are being advertised, or which routes are being advertised from one to the other.
All right, thanks, Paul. So
Philip, there was just one more question that's just come in as well. Can Megaport guarantee reliability and availability of the network connection if we're using the interconnect, if we use to interconnect data centers? Yeah, so all of this question is about connecting data centers together. So if you're going from DC to DC anywhere globally, we're using a meshed network. Each data center that we have has got at least 2 exit points. Many of the larger data centers will have many more than 2 exit points from those DCs. And then the network has many paths to get from one point to another. It is optimized for low latency, but if there was a network issue, then the connectivity would reroute. You wouldn't be aware of that change other than a potential increase in latency. So yeah, that resilience is built into the Megaport network. Thank you for that question. And I think, yeah, Philip, if you wanted to wrap up at this stage.
Yeah, so thanks, Paul. As I said before, very interesting, very insightful. A lot of good questions I think we got here. If you have got any other questions, please reach out to us, either to Antti or to one of us here from Megaport. We are always happy to help and get your questions answered. I think that was a really great session here today, and thanks for Ficolo for giving us the stage here and to present the capabilities we have together Ficcolo and Megaport. So over to you, Antti.
Yeah, thanks a lot, guys. This was really insightful. Like already said, it's been a great hour, and we're almost covered, or we have covered already 57 minutes. So there's 3 minutes left. I won't spend all of that talking, but thanks a lot. This was really insightful, and hopefully this gives some ideas how to actually utilize software-defined networking. And whenever you need network as a service or clouds as a service with Finnish security standards and Finnish service, Ficcolo is always happy to help. I thank you all for attending. Thanks all for listening.
I think Antti is frozen or dropped off, but we're hitting the hour anyway. So I will close the call now. And thanks,
Paul.
All right, thanks all for attending the session today. Thanks, Ficcolo, and have a good rest of the day. Thank you, and bye for now. Take care.
Bye-bye.